para ma-upload natin sa BBL for those na hindi makaka-attend. O kaya naman medyo may problema ang internet today. Okay, we're 28. So today we're going to discuss enzyme kinetics, no? So forward na tayo sa enzyme kinetics. Kasi ang instruction sa amin by third week, we're on the second week, ano? By third week daw ay magpa prelims na. So we'll try to have the prelims on the third week, next week. Kasi daw baka most probably merong break. Ano ba? 34, 35. Okay. So in the meantime, check ko yung attendance nyo. Levy and Pang. What can you do? Ano ba siya? Hindi tumutunog ang chat, ano? Labang issue. Sige. Levy and Nakbang. Aaron Paul Alasaas. Paul de Guzman is Alasaas. You're Mr. Alasaas. It's just the same. Paul de Guzman is Paul Alasaas, is Mr. Alasaas. Alias ka. Alexis Albano. Alexis Albano. Ayun lang pala ang problema. Dapat pala doon nila ako nag-check ng attendance sa ano. Abdullah Alonto. Bagal. Mr. Alonto. Ano kasi tumutunog eh. Aliyah Abirilia.
Present po, sir.
Ganun na lang. Can you do that? Carla Maribando. Kung may mic naman. Hindi kasi natunog eh.
Present po, sir.
That's better. Hindi lang. Mariel Banusia.
Present po.
Trisha Barcia.
Present, sir.
Jamaica Barrett. Jamaica. Wala si Jamaica. Maria Regina Diana Barlao.
Present po.
Jerby Bauson. Jerby. Maureen Borselas.
Present po, sir.
Thank you. Marian Caminos. Wesley.
Present po, sir.
Samantha Isabel Capiriña.
Present po.
Ashley Patrick Capuno. Ashley. Mia Jamie Del Penado. Christine Joy Di Marukot. Jomel Edna.
Present po.
Lalaine Imboltorio.
Present po.
Lenny Espaliardo.
Present po, sir.
Angeli Pay Estrella.
Present po, sir.
Vince Permano.
Present po, sir.
Okay. Austin Jimenez. Dana Higa.
Present po.
Thank you. John Kyla Larino.
Present, sir.
Sania Andre Mabilangan. Sanya Mabilangan. Jean Luis Manalo.
Present po.
Chloe
Present po.
Ibita.
Present po.
Michelle Marie Minelli.
Present po, sir.
Jonah Eliza Montoya.
Present po.
Rosel Iris Morpe.
Present po.
JD Francil Ortiz.
Present po.
Bren Julius Pablo.
Present po.
Jared Pagal.
Present po, sir.
Allen Edward Pasqua.
Present po, sir.
Crystalline Pereira.
Present.
Isabel Romo.
Present, sir.
Clarice Rosel.
Present, sir.
Julian Saba.
Present po.
Saira Sophia San Juan.
Present po.
Joanne Margaret Sarmiento.
Present po.
Patricia Maysol Mila.
Present po.
Alison Jane Santa Maria.
Present po, sir.
Michelle Ann Teres Tagalog.
Present po.
Leanne Jean Johnson.
Present po.
Jeneline Tudtud.
Present po.
Naira Umantud.
Present po, sir.
Roma Bilias. Roma. Okay. Let's continue our discussion. I'm going to share my PowerPoint. Ano?
Sir, excuse po.
Mm-mm.
Hindi daw po gumana yung mic ni Kapuno at Di Marukot pero present po sila. Nag-chat po.
Sige, sige. Check ko na lang. Check ko na lang later. Dali lang yung later. Hindi marukot ano?
Nakakapuno po.
Tsaka si Kapuno.
Apo.
Si Ashley. Okay na.
Sir, mabilangan po. Present. Late po.
Sige, sige.
Sir, Barat po.
Sandali. Mabilangan, okay na. Barret, okay na. Okay. Let's go. So I'm going to share my PowerPoint. Okay, so today we're going to discuss enzyme kinetics. Ano? Okay, so this is the enzymes lock and key theory. So basically ang sinasabi niya, parang this is an old theory. Ano? Basically ang sinasabi ng enzyme lock and key theory, parang merong shape dun sa enzyme na pit yung substrate, no? As you can see, 'di ba, merong opening na parang half circle, tapos yung substrate niya half circle din, may opening na triangle, tapos yung substrate triangle, yung shape, no? So pit siya dun sa enzyme. And then after that, after fitting on that particular shape, ipaprocess siya ng enzyme and then it will be converted to products, no? Ganyan yung enzymes lock and key theory. Of course, this is an old theory, ano? Pero mukhang valid pa rin naman kasi 'di ba nakita niyo naman kay Leninger at kay Stryer, ganoon din naman talaga yung nangyayari. Ano, pag kumabit siya dun sa enzyme, basically nandoon yung mga amino acids, di ba? Tapos i-treat nila yung substrate, tapos magiging product. So basically this is just the same, ano? We use the enzymes lock and key theory to summarize the reaction, to have a general reaction for enzyme and substrate. So this is our general reaction for enzymes. Ano? So S plus E, S is the substrate, E is the enzyme. You're going to form the enzyme substrate complex, ES. Okay? Generally, this is rapid, you know? Or it attains equilibrium very fast. Okay, so hindi ko lang kasi mahagilap yung yung tamang arrow, pero as you can see, this is the same as S plus E, and then you have K1, and then yung reverse na halimbawa K2, and then the product is ES. Remember, this is rapid and it is always in parang rapidly in equilibrium, in equilibrium tong unang reaction. So this is the first reaction mechanism, The second reaction mechanism is yung ES, will separate, and then basically your product is produced, So this is K3. And then generally this is slow. Yung production ng product ay slow. So we're going to apply the rate determining state theory, the RDS, tandaan niyo pang RDS, and the steady state assumption, SSA, to derive the Michaelis-Menten equation. Basically, this is the basic equation for enzyme kinetics, the Michaelis-Menten equation. So the Michaelis-Menten equation is B is the rate of the reaction, this one. This is the rate of the reaction, velocity, That's why it's B. And then B max is the maximum rate of the reaction. Itong B na to, this is the actual, while this one is the maximum possible rate of the enzyme reaction. S here, right here, this is the substrate concentration. Yung dalawang S na yan. This is the substrate concentration. So, halimbawa, glucose. Ano yung molarity ng glucose during the reaction? That's the substrate concentration. Okay? And then Km right here is the Michaelis-Menten equation. So let's try to derive this equation. I'm going to share a whiteboard. So let's try to derive the Michaelis-Menten equation. So magsisimula tayo dun sa dun sa basic equation. So S plus E, this is reversible. This is K1, this is K2. Tapos we have ES, and then generally this is in equilibrium, rapid and in equilibrium, Okay? And then next is yung ES naman, we're going to produce the product. This is K3. So we have the product plus enzyme. So this is slow. So apply muna natin yung RDS. Remember, RDS is the rate determining step theory. Anong sabi ng RDS? Okay. Sabi ng RDS, yung slowest step daw is the rate determining step. Diba? So because of that, yung rate natin, kasi ito yung slow, the rate or B is equals to K3 times concentration of E times S. Do you agree? Kasi di ba slow, so Gen Chem pa yan, di ba? Tapos probably nakuha niyo ulit sa kinetics. O kaya naman sa PChem, hindi ko lang alam kung naaabot niyo pa to sa PChem kasi ginawa ng 2 units ang PChem, pero dati naaabot dito sa PChem 2. Any question regarding the rate determining step conclusion? Okay, so if you don't have any question, next, we're going to apply the SSA or the steady state theory. Anong sabi ng steady state theory? Sabi ng steady state theory, the concentration of the intermediate, the change in the concentration of the intermediate is equals to 0. So basically that's dES dt is equals to 0. So how do we express this? Alin ba dito yung mga reaction na nagpo-produce ng ES? This one, yung forward ditong first reaction. Diba? So K1 times S times E. Okay? Tapos ito namang pabaliktad, yung reverse, yung K2, ano naman siya, nawawala naman yung ES. So minus siya, minus K2 times ES. Okay? Then this one, yung K3. Yung K3 naman nawawala din. So minus din yun, minus K3 times ES. Do you have any question at this point? So we'll just manipulate the second equation. So what we're going to do to transfer natin yung dalawang negative, ito at saka ito sa kabilang side. So Tapos we can factor out ES. No? We can factor out ES. Tapos what we're going to get is K2 plus K3 is equals to K1 times S times E. Question? Tapos we're going to let Km, the Michaelis-Menten constant, to be equal to K2 plus K3 divided by K1. So Km, in short, is equal to S S times E, no, divided by ES. Tama? Diba i-transpose sa kabila, you will have S times E divided by ES. Tapos sa kabilang side naman, you have K2 plus 3 divided by K1. Question? Okay. So next is kasi yung E, yung concentration of the enzyme, mahirap siyang i-measure, ano? So what we're going to do is we're going to, 'di ba we're going to use E total. This is the total enzyme na nilagay niyo sa system, ano? Yung total enzyme na nilagay niyo kasi sa system, nagiging dalawang form to. Yung isa, yung enzyme na hindi naka-bind sa substrate at saka yung enzyme substrate complex. Tama? Do you agree? So, yung concentration ng enzyme equal siya sa E total minus ES. Makinig kayong mabuti. I'm going to ask you to derive the Michaelis-Menten equation. Ano? Lumalabas to sa board exam. Of course, the Michaelis-Menten equation. Pero syempre, pag hindi nyo alam ang derivation, mahirapan kayong i-apply yan. Hindi kayo confident na i-apply yan. Ano? So that's why, try to listen. Okay, so we're going to replace E with E total minus ES. No? So we have Km, tapos concentration of S, tapos yung E, ito yon, E total minus concentration of ES. Okay, tapos divided by ES. Yan. Pindot ko. Okay, basically ang ginagawa ko is I will try to isolate ES, no? Tapos i-substitute ko dito, tapos yun, we're going to have the Michaelis-Menten equation, no? So may dalawa tayong ES, ano? May parenthesis yan dyan. So may dalawa tayong ES. What I'm going to do is I'm going to isolate this ES, ano? So first, i-multiply ko tong ES na to sa Km. So I have Km times concentration of ES. Tapos yung ES na isa sa kabila, itatranspose ko dito sa left side. So what we have is concentration of S times ES. Ano? Tapos ang matitira na lang sa kabila is S, concentration of S times E total. Mahaba kasi itong derivation na to, mahirap gawin sa collab. Okay, do you have any question at this point? So kita nyo na yan, ano? I'm just going to factor out ES. So pagka-factor out ko ng ES, kita nyo na yan, meron tayong Km plus S. So yun na yung magiging denominator. So we have S, tapos E, tapos total, ano? E total, tapos divided by Km plus concentration of S. Can you follow? So with this equation right now, i-substitute na lang natin dito. Ano? So mangyayari dyan, we have B is equals to K3 times concentration of S times E total. Okay, divided by Km plus concentration of S. So this is already the Michaelis-Menten equation. What is left for us to do is to substitute Bmax, to substitute Bmax dito sa K3 times E total. No? Yan, Bmax yan. Bakit Bmax yon? Yung K3 times E total. Bakit siya Bmax? Christine, ikaw yung nasa unahan. Bakit siya Bmax? Kasi, ano bang formula ng B? From the rate determining step theory. Anong formula ng B? Christine. B is equals to?
K3 times ES.
O nga pala, wala kang nga pala. Hindi, meron na. So, B is equals to K3 times ES. Bakit yung Bmax, no? Bmax, why is it the maximum B is equals to K3 times ET? Bakit, Christine? E total, total concentration of enzyme. Why? Why is Bmax equals to K3 times ET? E total. Total concentration of enzyme. Kasi Bren, baka alam mo, Bren.
Kasi po, sir, total po yung E eh. So,
Hindi.
mas maximum po yung B. Hindi po.
Yeah, tama. The maximum value of ES is E total. Tama, di ba? You get it? The maximum value of ES, concentration of ES, this one, the maximum value of ES is E total. So that's why K3 times E total is equals to Bmax. Nakuha yun? Okay lang? So if we're going to substitute Bmax here, we have Bmax times S divided by Km plus S. That is your Michaelis-Menten equation. So, okay lang? Do you have any question? The derivation? Nasundan ba? Do you have any question? Nasundan? Familiar sa rate determining step theory? Familiar sa SSA? Steady state assumption? Hindi masyado. Do you have any question regarding rate determining step? Ganito yung kwento niyan kung hindi kayo familiar. Halimbawa, palaging example diyan, dati kasi nung nung sa LB kami kasama ko si Sir Magas. Departmental palagi yung exam. So tulong-tulong kaming mag-check, no? Halimbawa ako mag-check ng multiple choice, Edgar yung mag-check ng problem. Tapos meron pang ibang teacher mag-check din ng problem, Bago ma-release yung exam, no? Dependent 'yon doon sa pinakamabagal mag-check. No? Kung sino yung pinakamatagal matapos. 'Di ba? Na-imagine nyo? Halimbawa kasi kahit na tapos na kami lahat. Halimbawa 11 yung mag-check, tapos na yung 10. Pero yung isa, hindi pa siya tapos. So bago ma-release yung exam, dependent siya dun sa pinakamabagal. That's the rate determining step theory. So that's why in this particular example, 'di ba ang pinakamabagal natin yung second step. So, yung rate ng reaction dependent lang siya dun sa second step. So K3 times concentration of ES. Okay? Question? Yun namang steady state theory. Yung intermediate kasi, hindi talaga yan nag-i-exist. Actually, ang concentration ng intermediate in reality is equals to 0. No, mabilis lang siyang mawala. Parang lang yan, temporary lang. Tapos nawawala siya. Hindi siya stable. So sabi ng steady state theory, yung daw change sa concentration ng intermediate is equals to 0. Just like how we express it right here, no? So yun, nakita niyo naman yung nakita niyo na minumultiply lang nung K yung mga concentrations. And then we just use some algebra to derive the Michaelis-Menten equation, no? Kaya niya algebra na lang. Tapos ang isa pa dito, ito E total, ES. Yung pang isang key. E total is equals to enzyme concentration plus ES. Ang init buksan mo sa bintana. Buksan mo. Question? Okay. So sana nag-notes kayo, So let's go back to our PowerPoint. Michaelis-Menten. So ito yung Michaelis-Menten. Ito din dinerive natin. Ano? Rate B is equals to B max times concentration of S divided by K sub M plus S. Do you have any question? Nakuha niyo na ba sa ano? Sa kinetics? Minsan kinaabot ito ng kinetics. 171? Hindi pa. So, kung hindi pa, let's try to listen. Let's try to solve this old board problem. Ano? In an experiment conducted to evaluate the Michaelis-Menten constant, it was found that 1 gram of bacteria could decompose the waste at a maximum rate of 35 grams per day. When the waste concentration was high, no? So this is Bmax, yung 35 grams per day, ano, Bmax yan. It was also found that the same quantity of bacteria would decompose waste at a rate of 18 grams per day. This one is B. When the waste concentration was 20 milligram per liter. This one is S. Yung 20 milligram per liter is S. Now, you are asked to calculate the rate of waste decomposition by 2 grams of bacteria if the waste concentration were maintained at 8 milligrams per day. Okay? So, you have the choices. So, basically, we're just going to use the Michaelis-Menten equation. Ano? Direct substitution lang. Dun sa first set of data, makukuha niyo yung Km. Kasi walang Km tayo sa problem. Ano? Sa first set of data, kukunin niyo yung Km. Tapos doon naman sa second set of data, isosolve niyo yung B. Kasi nasolve niyo na yung Km sa first set of data. Pero notice that, doon sa second set of data, yung bacteria nyo, o kaya yung parang enzyme nyo, ano? Yung bacteria nyo, 2 grams na. Dati 1 grams pa lang. So, ang mangyayari dyan, yung Bmax magdodoble din. So, nabawa, initially 35 siya, magiging 70. Ganun, ano? Let's try to solve this. So just try to recall. So recall lang that B is the Michaelis-Menten equation, ano? Is equals to B max times the concentration S, substrate concentration, ano? K sub M plus concentration S. So just substitute everything. Hindi naman everything. Substitute the correct, value of the variables, ano? So muna B max, B muna, yung B natin is 18. Okay, 18 grams per day. Tapos yung B max natin is 35 grams per day. Yung S natin is 20 milligram per liter, no? Okay, yung Km natin is yun yung hinahanap natin. Plus again 20. So from here you can see, no, kasi grams per day. You can see that Km should have a unit of milligram per liter, no? Milligram per liter. So just use your calculator, shift solve, tapos solve for K sub M value. Michaelis-Menten constant. You're supposed to get something like 18 35 times 20 alpha x plus 20, ano? Should solve. Ilan ang lumalabas? Patricia, Sulmila. Pag nawala, I will give you another link for Zoom. Tapos connect ulit kayo, ha? Pasensya na, you need to do that thing. Ano lumalabas? Patricia. Sino pa? Oh, Mr. Pablo, ano lumalabas sa calculator mo? Anyone? Sinong meron nasa calculator?
Sir, 18.89 po.
Okay, very good. Isabel, ano? 18.89. Unit nito ay milligram per liter. Okay, second set of data. Let's use the 18.89. Ang tinatanong naman dito ay B. So ang Bmax natin, kasi sabi ko nga sa inyo, 2 grams na siya. So ang Bmax natin, hindi na 35. No, hindi na 35. 70 na. 70 grams per day. Tapos yung S natin, hindi na rin siya 20. Ano? 8 na. So 8 milligram per liter. Can you follow? Ang Km natin, 18.89. Grams per, ano din to, ano? Milligram per liter. Plus 8 milligram per liter. So anong B natin? Unit muna, anong unit ng B? Dana, anong unit ng B? Velocity, rate of the reaction. The same as?
Gram per,
Yes,
gram per day.
grams per day. Okay? So, solve nyo. Anong letter ang sagot?
Letter C po.
Letter C. Very good. That's correct. Okay? Nakuha nyo? 20.8 grams per day. Do you have any question regarding this problem? Okay, kung wala, chat. Yes, very good. 18.18. Very good, Michelle. Very good, Rosel. And Allison. Very good. Let's try another one. Okay, this is the Line-Weaver-Burke plot. Basically, ano lang to? This is just take the reciprocal of the Michaelis-Menten equation. Ano? Just take the reciprocal. Di ba ang Michaelis-Menten equation is B is equals to B max times S divided by K sub M plus concentration of S. So just take the reciprocal. So if you're going to take the reciprocal, you will have 1 over B or 1 over R. This is the rate, ano? That's the velocity. So ito lang yun, ano? And then, yung first term, you will have K sub M divided by B max divided by S. So this is the first term, ano? Yung second term naman, as you can see, dito sa S, magka-cancel out yung S sa second term. No? This is S divided by S divided by B max. So matitira na lang is 1 over B max. So basically, the Line-Weaver-Burke equation is used for the determination of K sub M and B max if you have substrate versus rate data. No? Tama? So basically, yung yung y-intercept, you can use the y-intercept to determine B max. Tapos, yung slope naman, you can use that to determine Km. Correct? Okay. You hope you get it. Ano yan, di ba? Parang PChem lang, ano? Tawag nila sa PChem ay linearization. Physical chemistry daw is the science of fitting every phenomena in a line. Ay, bakit ka bumabalik? Anong gusto mo? Hindi ko alam kung masasolve natin itong problem na to before mag-laption time. Ano? Anyway, basta pag nawala, lipat kayo sa bagong link. 45 minutes lang kasi to. So again, this is an old board problem. The enzymatic hydrolysis of an ester occurs according to the following reaction. No? So ester, mga PATs, these are esters. Ano? So RC double bond O, this is an ester, derivative ng carboxylic acid. So plus water, and then your enzyme, parang gumagawa tayo ng carboxylic acid. No? Carboxylic acid yung product niya, plus ROH. So parang this is the same reaction as your soap reaction, no? Yung enzyme could be lipase, ganyan, ano? Anyway, these are the data. Yung substrate concentration, of course, this is the concentration of S. This one over here, the concentration of S. Tapos this is the V. This is your V or your R, no? Okay, so dun sa equation natin, dun sa Line-Weaver-Burke, di ba, we have 1 over B, no? So this is going to be the Y. So yun yung Y. Tapos is equals to Km, B max, okay, times 1 over S. So itong 1 over S, ito yung X, no? Okay lang? Tapos yung Y-intercept natin is 1 over B max. So basically, we're just going to perform linear regression on 1 over S at saka sa 1 over B. No? Tama? So, halimbawa, ang ating 1 over S is 1 over 3, tapos 1 over 4.5, etc. Ang 1 over B natin ay 1 over 0.051, Tapos 1 over 0.064, etc. Okay, so perform this. Marunong pa kayo mag-linear regression sa calculator? Subukan nyo nga. Kuha ng calculator at mag-linear regression. Baka nakalimutan nyo na ha, paano mag-linear regression sa calculator. Okay, and then pag nakuha nyo ang slope, yung A value, which is equals to 1 over B max, sabihin nyo kung anong nakuha nyo. Of course, I hope you're doing the calculator linear regression. Anyone for the slope? Sinong may bali na? Oh, Mr. Alonto, may value ka na ng slope ng line? Jomel, Edma, Derby, slope, wala pa? Leanne, the lane. What's the value of A from linear regression? Sabel, wala pa?
34.74 po ba?
B yun, B. The other one.
B.
B. That's
Yung
the
8.045.
8.045. Very good. So this is 8.045. Ito yung calculator mo, ano? Bali, ano to? Y-intercept, ano, Sabel? This is Y-intercept, ano? So with this,
po.
oo nga. So with this, you can calculate Bmax, ano? So Bmax is the reciprocal of 8.045, 1 over 8.045. Tapos, yung slope na lang para is equals to Km divided by Bmax. So sabi mo, ang slope natin is 34.74. Okay? So substitute nyo lamang sa, you can easily get K sub n. So i-multiply nyo lamang itong 34.74 ng 1 over 8.045. Or just basically, divide 34.74 with 8.045 to get Km. Km yung tinatanong. The Michaelis Menten constant is, so anong value ng Km natin? What is 34.74 divided by, hindi. Ano ba? Divided Bmax. Tama, multiply mo ano? So, divided by 8.045. That's the value. Km is, what's 34.74